Okay, so far we've talked about velocity and what it means. We said that velocity means displacement that is covered, displacement out of the time taken to cover that displacement. That is what velocity is. And we said since displacement can have either a negative or a positive, or it has direction, it can be positive, it can be negative, maybe in the opposite direction, it can be up and down, it can be at different angles. Yeah, velocity will also have those same characteristics. So you can have a positive velocity, that would probably mean that the object is moving forwards. Talked about this. You have a positive velocity, the object is moving forwards. If you have a negative velocity, the object is moving backwards. But most of the time in reality, objects do not stay at a constant speed. Their speed changes, and their velocity and their speed both change. And there's a term that we use in mechanics to describe changes in velocity, and we actually call it acceleration. Acceleration. When we say that a car is accelerating, in general it means that the car is speeding up. That's what we think of it as. If the car was moving at 40 meters per second, let's just represent the car with a circle, 40 meters per second, and then a second later, maybe after a while, maybe 3 seconds later, it's now moving at 60 meters per second. The speed has increased, and the increase here, we'll see that there's an increase from 40 to 60. It's an increase of over 3 seconds. But your speed can also reduce. You can start out at a speed of about 80, and then over another 3 seconds, this time maybe you're going 80 meters per second in that direction, and then after 3 seconds you're now moving at 20 meters per second, still in that direction. Maybe there's a barrier somewhere here, a stop sign somewhere there, and we'll call this all acceleration, though usually when the car slows down we'll say this is deceleration. How exactly do we calculate it? Well, first we need to see what is the change in velocity here. So how do we do that? Let's look at this first example. We start out at 40 meters per second, and then we are at 60 meters per second. We're actually still moving in the same direction. So the velocity here is just 40, and this is 60. So what has happened? It has increased by actually, how do we get from 40 to 60? We've added on 20 meters per second. And how long did it take us to do that? It took us 3 seconds to add on 20 meters per second. So we can think of it as over those 3 seconds we added on 20 meters per second. So if we divide this, we'll actually get something like 6.66 meters per second. So we increased our speed by 6.66 meters per second every second. So that means in the first second we added on 6.66 meters, so maybe we were at 46.6. Then after another 1 second we added on another 6, so maybe we were around 53 point something. And after another 1 second we added another 6, then we finally arrived at 60. So it took us 3 seconds, and in each of those seconds we were adding on 6.66 meters per second each second. So that's where our unit comes from, 6.66 meters per second each second. That's how much speed is added on each second. What if we look at this position here where the speed is reducing, the velocity is reducing? So we have 80 meters per second in that direction, then we have 20 meters per second still in that direction. So what happened to the velocity here? Let's look at that. It seems to have decreased, but by how much has it decreased? From 80 to 20. What's the decrease there? It's actually a decrease of 60. We've subtracted 60 meters per second. Over that time period, maybe the ball, maybe the car, the speed has reduced by 60 meters per second. And how long did it take for that decrease to happen? It took 3 seconds. So we want to see each second how much speed was reduced, and we'll actually get 20. This will give us negative 20 meters per second. So the ball is moving this side, and for each of those seconds the speed reduced by 20 meters per second each second. So in the first second possibly it went to 60, then thereafter it was at 40, then finally there was a jump to 20. So that's what these units mean, but in general we'll not write them out like that. we'll actually write them out as instead of writing out the unit as meters per second, in general we'll write it out as meters s to the power negative 2. That's how we'll write it out in general, to simplify, so to prevent confusion and the disorder of these two slashes. Now let's formalize this. Let's get an actual formula for this, something that we can use in general. So for an object moving at a certain velocity, I'm going to introduce a few new symbols, say 20 in that direction, and then this one is moving at 30 in that direction. It's the same object, but this happened over 2 seconds. I'm going to introduce a few new letters. We'll say that the initial velocity, the initial speed, the speed at the start, we are going to call that the initial velocity. And right here, we're going to call this the final velocity. So what is the initial velocity? We're going to label it u, and the initial velocity is 20. And for the final velocity, we're going to label that v. Final velocity will be v, just like that. And for the time, we'll use t. And for acceleration, we'll simply use a for the acceleration. So let us see. There's acceleration here because the object is increasing speed. The formula will actually look a little bit like this. Acceleration, we're going to find the change in velocity, and the change in velocity here is, the velocity here is 30, so we're going to get the final velocity, subtract the initial velocity, and then divide that by the time over which that change happened. Or in other words, you can see this working out. You can see how this works out. Have a equals v minus u. So have 30 minus 20 divide by 2 seconds. And these are in meters per second. The units are quite important. And so finally, we'll have something that looks like 30 minus 20 is 10. Say equals 10 meters per second divided by 2 seconds. So the change in velocity is actually going to be 5 meters per second. So for each second in this scenario right here, the speed increased by 5 meters per second for every single second. The first second it reached 25, then the next second it reached 30. And that's the key idea for acceleration: change in velocity out of time.